Oceanic trenches are narrow, long, prominent depressions of the ocean floor. They are typically 50 to 100 kilometers, 30 to 60 miles, wide and 3 to 4 kilometers, 1.9 to 2.5 miles, below the level of the surrounding ocean floor, but can be thousands of kilometers long. There are approximately 50,000 kilometers, 31,000 miles of oceanic trenches worldwide, mainly around the Pacific Ocean, but also in the eastern Indian Ocean and a few other locations. Let's take a look at the largest and deepest ocean trenches that Milk T2K has compiled. The Puerto Rico Trench is located on the boundary between the Caribbean Sea and the Atlantic Ocean. The Oceanic Trench, the deepest in the Atlantic, is associated with a complex transition between the Lesser Antilles subduction zone to the south and the Major Transform Fault Zone or plate boundary, which extends west between Cuba and Hispaniola through the Cayman Trough to the coast of Central America. The trench is 800 kilometers, 497 miles, long and has a maximum depth of 8,376 meters, 27,480 feet, or 5.20 miles. This constitutes the single deepest point in the Atlantic Ocean. This point is commonly referred to as the Milwaukee Deep, with the Brownson Deep naming the seabed surrounding it. However, more recently, the latter term has also been used interchangeably with the former to refer to this point. The exact point was identified by the DSSV pressure drop using a state-of-the-art Kongsberg EM-124 multi-beam sonar in 2018, and then directly visited and its depth verified by the Crewed Submersible Deep Submergence Vehicle DSV limiting factor, a Triton 36000/2 model submersible, piloted by Victor Vescovo. Scientific studies have concluded that an earthquake occurring along this fault zone could generate a significant tsunami. The island of Puerto Rico, which lies immediately to the south of the fault zone and the trench, suffered a destructive tsunami soon after the 1918 San Fermin earthquake. The Japan Trench is an oceanic trench part of the Pacific Ring of Fire off northeast Japan. It extends from the Kuril Islands to the northern end of the Izu Islands, and is 8,046 meters, 26,398 feet, at its deepest. It links the Kuril-Kamchatka Trench to the north and the Izu-Ogasawara Trench to its south with a length of 800 kilometers, 497 miles. This trench is created as the Oceanic Pacific Plate subducts beneath the continental Okhotsk Plate, a microplate formerly a part of the North American Plate. The subduction process causes bending of the downgoing plate, creating a deep trench. Continuing movement on the subduction zone associated with the Japan Trench is one of the main causes of tsunamis and earthquakes in northern Japan, including the megathrust Tohoku earthquake and resulting tsunami that occurred on March 11, 2011. The rate of subduction associated with the Japan Trench has been recorded at about 7.9 to 9.2 centimeters, 3.1 to 3.6 in/year. The Kuril-Kamchatka Trench or Kuril Trench is an oceanic trench in the northwest Pacific Ocean. It lies off the southeast coast of Kamchatka and parallels the Kuril Island chain to meet the Japan Trench east of Hokkaido. It extends from a triple junction with the Ulakan Fault and the Aleutian Trench near the Commander Islands, Russia, in the northeast, to the intersection with the Japan Trench in the southwest. The Kuril-Kamchatka Trench has a maximum depth of 9,600 meters and has the second largest habitat area, after the Isobonin Trench. Investigation of documents collected by the German-Russian expedition Kurumbayo-2, RV San, 2016, 8 stations, and 3 Russian expeditions, RV Vityaz, 1949, 1953, 1966, 16 stations, from the Hadal region of the Kuril-Kamchatka Trench, depth 600 to 9583 m. The trench formed as a result of the subduction zone, which formed in the late Cretaceous, that created the Kuril Island Arc as well as the Kamchatka Volcanic Arc. The Pacific Plate is being subducted beneath the Okhotsk Plate along the trench, resulting in intense volcanism. The Chromatic Trench is a linear ocean trench in the South Pacific Ocean. It stretches about 1,000 kilometers, 620 miles, from the Louisville Seamount Chain in the north, 26 degrees south, to the Hikurangi Plateau in the south, 37 degrees south, northeast of New Zealand's North Island. Together with the Tonga Trench to the north, it forms the 2,000 kilometers, 1,200 miles, long, near-linear chromatic Tonga subduction system, which began to evolve in the Eocene when the Pacific Plate started to subduct beneath the Australian Plate. Convergence rates along this subduction system are among the fastest on Earth, 80 mm, 3.1 in/year in the north and 45 mm, 1.8 in/year in the south. The chromatic trench is one of Earth's deepest oceanic trenches, reaching a depth of 10,047 meters, 32,963 feet. Formed by the subduction of the Pacific Plate under the Indo-Australian Plate, it runs parallel with and to the east of the Chromatic Ridge and Island Arc. The Tonga Trench marks the continuation of subduction to the north. The Chromatic Trench has a southern continuation in the turbidite-filled Hikurangi Trough, but a series of seamounts on the Australian Plate act as a dam and prevents this turbidity from reaching the sediment-starved Chromatic Trench. Debris from a larger subducted seamount probably dammed the trench from 2 ma to 0.5 ma, and similar events probably redirected sediments in similar ways before that. Two oceanic plates meet at the Chromatic Trench, which is located far from any larger landmass. Because of this, the Pacific Plate as well as the trench itself is only covered by 200 meters, 660 feet, of sediments. The trench is almost perfectly straight, and its simple geometry is the result of the uniformity of the subducting seafloor. This seafloor formed at the extinct Osborne Trough, located just north of the Louisville Seamount chain. Abyssal hills on the subducting seafloor are oriented perpendicular to the old spreading center, and the seafloor is 72 to 80 ma near the Louisville Seamounts at the northern end and more than 100 ma near Hikurangi Plateau at the southern end. There are no seamounts on the seafloor near the Chromatic Trench except one sitting on the trench slope at 31.50 degrees south, 176.45 degrees west, which has been dated to 54.8 plus or minus 1.9 ma. The Hikurangi Plateau formed part of the Ontong Java Manihiki Hikurangi Large Igneous Province, LIP, during the Ontong Java Event 120 Ma. The Manihiki Plateau is currently subducting under the southern part of the Chromatic Arc, but most of it has already been subducted. The LIP Arc collision occurred 250 kilometers, 160 miles, north of its present location, but oblique plate convergence has migrated the subducted plateau southward. The Philippine Trench, also Philippine Deep, Mindanao Trench, and Mindanao Deep, is a submarine trench to the east of the Philippines. The trench is located in the Philippine Sea of the western North Pacific Ocean and continues NNWSSE. It has a length of approximately 1,320 kilometers, 820 miles, and a width of about 30 kilometers, 19 miles, from the center of the Philippine island of Luzon trending southeast to the northern Maluku island of Halmahera in Indonesia. The trench reaches one of the greatest depths in the ocean. Its deepest point is known as Galathea Depth and reaches 10,540 meters, 34,580 feet or 5,760 fathoms, the Philippine Trench in the east, which continues downward, and the Philippine Mobile Belt. Immediately to the north of the Philippine Trench is the East Luzon Trench. They are separated, with their continuity interrupted and displaced, by Benham Plateau on the Philippine Sea Plate. The Philippine Trench is hypothesized to be younger than 8 to 9 million years old. The central part of the Philippine Fault formed during the Pliocene times is considered to be an active depression of the Earth's crust. The trench formed from a collision between the Palawan and Zamboanga plates. This caused a change in geological processes, creating a subduction zone that is dropping the ocean floor deeper. The rate of subduction on these plates is estimated to be about 15 centimeters per year. A convergent zone borders an estimate of 45% of the Philippine Trench today. The Tonga Trench is an oceanic trench located in the southwestern Pacific Ocean. It is the deepest trench in the southern hemisphere and the second deepest on Earth after the Mariana Trench. The fastest plate tectonic velocity on Earth is occurring at this location, as the Pacific Plate is being subducted westward in the trench. The deepest point of the Tonga Trench, the horizon deep at 23.25833 degrees south, 174.726667 degrees west, is 10,800 plus or minus 10 meters, 35,433 plus or minus 33 feet deep, making it the deepest point in the southern hemisphere and the second deepest on Earth after the Challenger Deep in the Mariana Trench. It is named for the research vessel Horizon of the Scripps Institution of Oceanography, the crew of which found the deep in December 1952. As one of the deepest hadal trenches, the sediment of the Horizon Deep harbors a community of roundworms. A 2016 study found that the abundance of individuals in this community is 6 times greater than it is at a site on the trench edge approximately 6,250 meters, 20,510 feet, near the deep, and that the difference in biomass between these locations is even bigger. Species diversity, on the other hand, is twice as big on the trench slope, probably because of a small number of opportunistic species in the trench. Figures for abundance and biomass are similar for the deeps of the Mariana Trench but considerably lower in the Peru-Chile Trench. The Mariana Trench is an oceanic trench located in the western Pacific Ocean, about 200 kilometers, 124 miles, east of the Mariana Islands. It is the deepest oceanic trench on Earth. It is crescent-shaped and measures about 2,550 kilometers, 1,580 miles, in length and 69 kilometers, 43 miles, in width. The maximum known depth is 10,984 plus or minus 25 meters, 36,037 plus or minus 82 feet, 6.825 plus or minus 0.016 miles, at the southern end of a small slot-shaped valley in its floor known as the Challenger Deep. If Mount Everest were placed into the trench at this point, its peak would still be underwater by more than 2 kilometers, 1.2 miles. At the bottom of the trench, the water column above exerts a pressure of 1,086 bar, 15,750 psi, more than 1,071 times the standard atmospheric pressure at sea level. At this pressure, the density of water is increased by 4.96%. The temperature at the bottom is 1 to 4 degrees Celsius, 34 to 39 degrees Fahrenheit. In 2009, the Mariana Trench was established as a U.S. national monument. Monothalamia have been found in the trench by Scripps Institution of Oceanography researchers at a record depth of 10.6 kilometers, 6.6 miles, below the sea surface. Data has also suggested that microbial life forms thrive within the trench. The Mariana Trench is named after the nearby Mariana Islands, which are named Las Marianas in honor of Spanish Queen Mariana of Austria. The islands are part of the island arc that is formed on an overriding plate, called the Mariana Plate, also named for the islands, on the western side of the trench. If you find this video interesting and useful, please share it and give it a like. Please subscribe to the channel and the bell button to not miss any latest videos.